Hello, everyone. I'm John. I'm a software engineer at Twitch, a member of the Ruby diaspora, if you will. Basically, people who used to write web servers and then got sick of the GIL. And I'm also a bit of a video nerd, as you can imagine. So let's talk a little bit about the outline of my talk. I'm going to ask, why are we going to do this? Why are we going to build an interactive video streaming thing in Elixir? And I'm going to talk about Ffmpeg, because if you're going to do that, you probably want to use Ffmpeg. I'll also talk about Elixir and Shell. Then we'll go into building a transcoding pipeline, and eventually streaming a video. We'll see how that one goes. So why would you do this? Building interactive video streams is pretty fun. There's plenty of examples actually out there of some really cool ones. Twitch Plays Pokemon, for those of you who aren't aware, was an effort by someone who put up a Game Boy Color attached to Pokemon and attached that to chat so that people in the chat room could chat and play Pokemon. Another example was that came up recently was somebody put a large sum of money in a Robinhood account and had people day trade it for him from the chat room. So our example is not going to be nearly as expensive as that one. We're going to be building out a voting, small little voting app, just that tracks voting over the course of time. Probably won't expose it on the network just so that we don't deal with hotel Wi-Fi problems, but we'll see how that goes. So to get started, let's talk a little bit about Ffmpeg. Ffmpeg is a library that's pretty awesome for dealing with video. It's on their site, they call it a complete cross-platform solution to record, convert, and stream audio and video. The license depends on your compile flag, so if that's something you're worried about, be careful about that. Ffmpeg's pretty amazing. It lets you take in videos of a format and convert them to another format, just like locally. But it's actually more amazing than that, because one of the possible outputs that you can do is outputting the video itself to standard out. And if you're spitting out an Mpeg TS file, that means that you can chain that and put that into something else. ffplay is a tool that ships with Ffmpeg that lets you inspect the video and interact and just see some of the metadata and debug it. We'll probably be streaming to that by the end of this talk, but in reality, what you'd be doing would be chaining it to the end with something pointing to your service provider. So we're going to transcode the video to adjust the keyframes, chunk the video to every second, and apply a filter to the video. And then finally, if all works well, we'll stream the video to our favorite service provider. So Ffmpeg lets you take in an input and then apply filters. X264, one of the fun licensing ones, has these options that you can set in it. We're going to change the keyframes to be every 30 frames. That way that we put the keyframes every second. The reason we're doing this is just to make sure that our chunks are of small sizes. Otherwise, we end up with large chunks that become a little unruly to deal with. The next step we're going to do is to avoid having to parse the Mpeg TS files in Elixir, although that's not too bad. You can take a look at some of the interesting libraries out there with early video. You can see that all we're going to do is we're going to convert them to a bunch of small files, as you can see over here, and just save them locally so that we can then stream them. Now, this transcoding flow is something that we do ahead of time so that we don't have to rely on a live transcode on the stream, or to save as much work as possible come live stream time. And then finally, the final flag to how to stream if you have, if you've picked the live streaming service provider that you want to stream to. They all use RTMP for the most part, and that just means passing in a -f-FLV flag followed by your, the RTMP address and the stream key that they provided. All right, now to talk about Elixir and Shell. Elixir and Shell have an interesting story because unlike some systems languages, it doesn't necessarily deal with signals well, so there's some issues around there, but we'll get to that in a bit. So os.cmd, it works. That's what could be said for it. The cons is it reads only from standard out, and it's pretty much only a char list, actually, not even a string. There's a system.cmd that does the conversion for you that's built into Elixir, and there's no streaming support, which is problematic if you want to do something that doesn't end, because it ends up flooding your memory. Then there's Erlang Ports. Erlang Ports have a process.send sort of interface that play really well with OTP, and it also supports standard error output. That's sort of critical for Ffmpeg logs, because if you're spitting out video on standard out, you don't really want to spit out the logs in the middle of it. Sort of messes up your video. But the main con, of course, is that it doesn't really send OS signals to external processes, like I was mentioning earlier. Now, what that means is that if you turn off your Elixir program, it tends to leave a bunch of garbage lying around. There's ways to clean it up, of course. Some people put in pkills at open or close or something, but in general, it's not the cleanest. So let's talk about one of the interesting open source libraries out there, Porcelain. Porcelain is built on top of Ports, and it supports flexible output formats like stream and binaries, and it also lets you append to file. It's pretty flexible. It requires a Go dependency for some of the features. So if you're really interested in looking at Go stack traces at every time you close your Elixir app, this is the library for you. And there's some instability when reading from both standard error and standard out at the same time, because what it basically does is it spins out a Go process that it can then talk to, and then that Go process is the one that manages the cleanup and the signals to whatever Unix process you're doing downstream. And you can send, and it would manage sending other signals to the downstream processes. And you could talk to it over whatever it is, because it's a process, right? And in terms of options, it's also really solid. If you want to have a string, just a raw Unix string that you could just execute, porcelain.shell and spawn shell are available for synchronous and asynchronous. And if you want to have the other format, where you'd have the command followed by arguments as a list, porcelain.exec and porcelain.spawn are also available. So let's move on to transcoding video in Elixir. So we now have the layout, right? We have Ffmpeg that can be used to transcode, and we have Elixir. We can now shell out of Elixir, so let's talk about this. So the step, like I mentioned earlier, helps reduce a lot of the work done at stream time. The basic flow that we're going to build is GenStage, producer, consumer supervisor, transcoder. And what this means is, at the end of the day, we don't have to do a lot of the annoying orchestration that's often involved in building out a worker framework. But there's some things that we end up having to work around. So let's look at this for a second. Standard GenStage start logic, but I also start a timer to send interval check demand. This basically spams us and tells us to go check the demand, because while I would, in production, I would highly recommend against this. In this example, we'll be using our file system as a queue. And so to do that, we'll just be reading from the file system periodically to see if there's any jobs left for us to do. Here we have the handle info for check demand, which just recurses to the handle demand, pseudo recurses, I guess, with demanding 0 but checking the state. And in this case, we'll check to see if the demand plus the buffered demand is greater than 0. Then what we do is we go and we pull files from our directory to see if we should transcode anything. Now, to do this pulling logic, we want to make sure we're not spamming and doing the same job over and over again. So we add basically a lock file and a done file, if you will, that checks to see the lock file. We check it periodically to see its M time, and we also check the done file to see if the job's already done and we don't need to do it. And then finally, we can take the lock by touching the lock file. And I've omitted the helper methods because that's pretty much all they do. Let's talk about the Transcode Consumer. For those of you who aren't familiar with Consumer Supervisor is a great abstraction over the standard consumer. It lets you spin up a generic task, essentially, for each event that comes in. And that means that it basically simplifies the code of whatever you're doing on the other side. And in this case, we're going to be transcoding video. So to transcode the video, what we do is we start link with a task, and we keep the lock while alive. And all that's going to do is ask if the process is alive and touch the lock file, and then go do it again if the next time in basically some in some period of time, the heartbeat, which is 5 seconds here. That way, the transcoder just keeps touching the file and makes sure that everything is hunky-dory so that somebody else doesn't try and pick up the job and just start spinning my CPUs like crazy. Transcoding functions, really simple. Erlang has a decent function that ensures the directory. We ensure the directory exists. We write the function that that calls Ffmpeg, spits out the transcode path, and then the chunk, as we saw earlier, is piped in from that and takes the transcode path and chunks the file into its requisite 1-second chunks. Again, this could be done in this chunking could be done in Elixir, and it could be done at stream time. But just for now, we'll keep it simple. So next, let's spend some time talking about streaming video. So streaming video is essentially 3 steps. It's streaming it, applying filters, and then making it parallel. That should have a beta flag next to it. Here's like the standard blocking start stream, right? We have a directory, and we take in the directory, read the bytes, and then apply the filter, and then play. Pretty simple. Reading the bytes, since we've already Ffmpegged it, it's already in an MPEG TS format, and TS is a concatable file format, which means we can just keep on attaching it one after the other. All we do is we read the file, and we wrap it in a list, pass it along to apply filter, which then takes in those bytes and lets you output it as a stream. Remember how I mentioned that Porcelain lets you output in a variety of formats. Outputting it in a stream is really handy when it comes to not trying to flood your own memory. So we have the options here, and then we also go and ask the voter to get the results. The voter is a basic gen server that I wrote just to get basic voting functionality, and it lets you vote yay or nay depending on what you click. And then we spawn out an Ffmpeg process. When you spawn it out, that's an asynchronous call. So whatever's returned from there is in the output over here, which we return at the end of the function. As you can see here, this giant scary blob of text is some of the video filters that you can do in Ffmpeg. In this case, we'll be adding an overlay. The overlay will have the number of yays, the number of nays, as well as the timestamp in seconds, because again, don't want to quite network this given the Wi-Fi situation. Oh, and this is the voter. The voter's actually just pretty simple. It starts out with a yay nay, and I wanted to write this thing just so that I can add the pun of a gen server cast to cast your vote. So let's talk about how to stream it. This is where I take the shortcut and don't use the live network. So a couple things that you see here. First, this is an example of how you would parallelize it. In my experience, it actually hasn't been necessary because you could just Ffmpeg runs fast enough. But for some cases, if you're doing a really complicated filter that doesn't quite render at real time, you could, in theory, just parallelize it and then run multiple Ffmpeg threads, processing different parts of the video. That does mean you have to do some bookkeeping and orchestration because you can't use the system time and you have to start calculating what time, how long it's been and all this stuff. But for the most part, you could just rely on the live stream for now. And then we stream flat map it out because task async stream returns a tuple of OK bytes. And then finally, we can spawn the shell. Now, the whole purpose of this slideshow in a browser is so that I can click this button, and if my Elixir process is up, it should start streaming. This is an open source video, the bunny file. Very, very useful for video demos. And with some delay, I can click yay and nay, and ta-da, we have votes. And the overlay, of course, comes in from the previous slide. Cool. Let's quit out of that. It's a very entertaining video. I recommend you watch it. All right. let's talk about a wish list. So, I do use Elixir at my day job to do very similar stuff to this, and so I've run into some fun issues. Porcelain doesn't quite support high volume writes to standard out and standard error at the same time. It runs into a weird issue where it's not quite tagged with the right code. So that probably is a bug that needs fixing, but it's pretty annoying to reproduce. I've only run into it after streaming for several hours, which is annoying. The other issues that we've seen, I wanted to use GenStage for this, and in fact, I have a branch that uses GenStage for this, but because it doesn't support ordered outputs, I couldn't do the real fun next step of just, spitting it out. It supports it, but you need to dive in a little deep and take a look at take sort and windowing. It becomes a pretty complicated situation. So if there was a fun ordered is true flag on GenStage, on a GenStage output, that would be really nice, but I'm sure that there's good reason for that not to be there. And then there's, transcoding video is remarkably expensive on your CPU. It tends to run your CPU pretty hot. And so ideally you'd use your GPU, and there's flags to do that on Ffmpeg, but if you're in a production environment where you're on the cloud, sometimes getting GPU boxes is a little complicated. Add on to that the layer of Docker, and you all of a sudden decide that CPU transcoding is just fine, and you continue, and you're very happy with that. Part of what influences a choice for Elixir for something like this is obviously if you have a live video connection, hot code reloading becomes a really nice asset. But Docker again stops me in my tracks there. This code is live over at johnwahba/vdemo. That's my Twitter and that's my GitHub. Thank you very much. Any questions at all? The GitHub repo is above, right there. It is very messy code, I will warn you.
I'm curious if you looked at Flow.
Yeah.
Flow library for some of the dealing with the windowing and partitioning and ordering.
Yeah. So I did have that's a great point. I did have another branch that did try and use Flow. The problem that I've seen with Flow is that at the very end, when I wanted to convert Flow into a stream, it's not necessarily trivial. What you run into is some issues with demand. There's a closed issue on Flow by IJCD. You should take a look at. But basically, when you try and pull out the demand, it starts trying to buffer a very large sum of things before even starting your process. So, Flow is an obvious good choice for something like this. But yeah, I ran into that problem.
Questions?
Do you know if there's like plans for Porcelain to use the OTP20 signal handling?
That's a good question. I have, from what I can tell, Porcelain hasn't really been iterated on in the past year, so likely not. But I could, I mean, presumably, there's nothing stopping you from forking it. But yeah, that's the current state as far as I could tell. And the Golang process obviously is a bit of a hack, but it does the job. Erlang what, sorry? ElixirConf? Okay, I'll take a look at that. Yeah, it sounds. Is that like another orchestrator for?
Process that runs alongside the VM to actually manage the processes, but it's much better at sending signals to those processes, all that kind of stuff.
Oh, good.
Which I had trouble with Porcelain. I was using it a while back, and I switched to ElixirConf. It was going well. So, yeah.
Thanks.
Questions? No more questions? Thank you.
Thank you, guys.